Hello everybody, this is the first video on my channel that is all in English language, and I choose this because the theme of this sequence of videos will be very important, and I believe that using English language will be very important to talk with people around the world about two important questions that are surrounding us and halting us at this time. And we have the something about the artificial intelligence evolution, and some issues about supply chain logistic crisis, and how artificial intelligence evolution can help solve the supply chain logistic crisis. So here we have a very important pictures about this, but we're gonna start about talking about. Uh, I know that everyone knows about Elon Musk, and many times Elon Musk talk about the danger of artificial intelligence, and in this particular video in YouTube, he said that he thought that the danger of artificial intelligence is much greater than danger of nuclear warheads. So and also he tried to solve this problem. He tried to convince people to slow down artificial intelligence, to regulate it, but it was futile. Okay, he tried for many years, and this didn't happen. Okay, and what is the real problem that Elon Musk pointed out is that artificial intelligence is quite close to the cutting edge, um, and to be a very scare. Almost artificial intelligence. We have artificial intelligence, for example, doing some activities like programming or driving cars, or even piloting aircrafts. So, and also the capacity of artificial intelligence is almost has a great rate of improvement, which is exponential. So it what scared Elon Musk, and also it's important to say this a very interesting book from Yuval Noah Harari, and in this book, Yuval Noah Harari describes how Google, Facebook, and other algorithms are already today omniscient oracles, and you can say that they command what you decide to see. For example, imagine that you are using a cell phone, and then you are using some social network, and the social network decides what's better to you to see, to make you engage in this social network. So we are already in control of some algorithms, and that is the main issue in the view of some people. But I believe this is not a very bad issue, because as Elon Musk already said in the same video that he is afraid of artificial intelligence, he said that we are already cyborgs. So we have a machine extension, your cell phone, your computer, um, can make you a superhuman. Now imagine you can contact anyone at any time, or send videos or send material in a very fast way. So you can communicate with many people. We can receive material, we can receive news. So we are dealing with new with this new superpower. And sometimes this superpower is not very good used, but can be used in a very good way. And I will show how this can be used in a very good way. So now we're gonna talk about a very important problem. Is the disruption of supply chain. Here we have some news about disruption, And here we have a photo, a picture about a container port. And with this congestion is in Yichang port in China. But we also have United States facing some supply chain crisis. And here we have President Biden talking about this and about these bottlenecks and shortages that are making supply chain crisis very, very, very bad. So President Biden announces two biggest U.S. ports to operate 24 hours, 7 days to ease the supply chain disruption. But I believe this problem is much, much, much difficult than just build ports, and we're gonna see why. And what's happening exactly? We have this text talking about this, explaining this. Since the pandemic started, 20 Americans have been on an extraordinary buying spree. And what happened? Outside the congested ports of Los Angeles and Long Beach, the entry point for about 40% of goods imported in the USA. So we have in Los Angeles and Long Beach congestion in the ports. And to imagine what this means, the quay of ships stacked with uh, brightly colored containers reached a record of 7 free uninsured container ships on September 19. So let's see this congestion. And here we have a map with the pointing the container ships and the ships trying to get the port to load or to unload cargo. Here we have the port. It's very, very complex environment here. Oh, let's see the picture here. We have the picture here. I was inside the picture. Okay. So see that it's very complex to organize and to make this more efficient or coordinate the actions here. And that's the point. How you can coordinate your resources or your planning in this complex environment. And just not this port, you have to imagine that we have a network of ports. And that is the main question, because if you have a delay in this port, this ship will be delayed for other ports. And that is the true question here. Here we have a marine traffic picture. It's a system that tracks the container ports or many other types of ships around the world. And as you can see here, it's just a little mess here to track all containers, all ports, all ships. It's a very, very complex task. It's not easy to know where is the bottleneck here. It's almost the same question to where is Wally here. I don't know. It's very difficult to answer properly this question. So, what we can do, I believe, truly believe, that we can use a very interesting idea that I developed for the 13 years, during 13 years, that is representation by rules. So I already applied this in many environments. For example, I already define represent or apply this approach to define the operations of forklifts to process tasks in a warehouse and in a very fast planning. This approach enables a very fast planning. That is the main issue here. We need to map the process and the tasks for example, a warehouse, or to use another equipment here to organize cargo for clients. For example, this operation of layer picker. Layer pickers adapted forklift, but this can use this to grab cargo and to make different piles of cargo. So we applied representation by rules in these two situations. And as you can see, if you can apply the same approach in different contexts, you can, therefore, you can use this to couple the problems. And we already present in this year in this International Congress about simulation modeling methodologies. We talked about, and we'll talk in the future videos, on the implementation of simulation based on representation by rules methodology to plan port logistics operation, fastly plan port logistics. Remember, we have many resources, we have many agents, we have a very complex context, how we can plan fast, how we can integrate many equipments in your planning. That is the main issue, and I'm gonna talk in the future video, in the second video, in the next video. So in the third video, I will talk about how we can automatically generate these rules. Because we are using representation by rules, each equipment will have a rule, but can be not much quickly to program the rule that will be used for each equipment. So we can develop a technique that can fastly create many rules. So imagine that each equipment will have a rule to operate, and you can program this equipment. You can automatically generate, a computer can automatically generate many rules as possible, and then you can simulate what is the best integration equipments with these rules. So I will talk more deeply about this in the third video of this series. Okay, that's enough for the first video. I hope you enjoyed, and if you have any comment, please use this channel to talk about or to see. My intention is to first see what's the reaction of this or the public to about this video, and then I can show some codes that I made in Python. Particularly, it's very fast, it's very easy, but I use my experience of 13 years working with this. That's it. Thank you for your attention, and I hope you enjoyed, and I see you on the next video. Bye.